In this video, we want to find the limit as x and y approach 0, 0 of x cubed sine y over x squared plus y to the fourth. In order to solve this, we're going to let x equal r cosine theta and y equal r sine theta. So recall that this is the polar form. And so as x and y approach 0, 0, basically we'll have 0 is equal to r cosine theta, and then 0 is equal to r sine theta. You treat theta as a constant, so if you divide both sides by cosine and sine, assuming they're at 0, you're going to get r equals 0. So this is the same thing as saying r approaching 0. Okay, so now we make the substitutions into our original limit here, and then apply the cube, square, and the fourth power. And then from here, we're going to move the cosine cube to the side, and this is more just to better understand what I'm doing, because it's kind of all convoluted, it's all together. So the next step is to factor out a r squared in the denominator. And so we have r squared times the quantity cosine squared plus r squared times sine the fourth. Now the r cubed over r squared just becomes r. And then from here we can plug in r equals 0. So we have 0 times sine of 0 times sine theta at the top, which 0 times sine theta, this is going to be 0. And then sine of 0 is 0, so you have 0 times 0 at the top, that's going to be 0. And over here, we have 0 squared with 0 times sine the fourth, that's also going to be 0. Okay, so you have 0 over cosine squared plus 0, that's just going to be 0 over cosine squared. And then we're going to multiply that by cosine cubed. And really at this step you can say, okay, this is just going to be equal to 0, because 0 times anything is 0. But I just went ahead and simplified it just for fun. Cosine cubed over cosine squared becomes cosine, and then 0 times cosine is 0. And so our final answer is going to be 0.